Okay, thank you. Hi. My name is Siyu Chen, and I'm a PhD student at Technion and a researcher at Trimble Solutions. Today, I will be presenting my research on a concurrent design paradigm for interdisciplinary design collaboration. I will be sharing the exciting insights from focus group study. So, as we all know that the modern building design requires close collaboration among stakeholders from different disciplines, including architects, engineers, contractors, fabricators, etc. However, the way people are collaborating still remains sequential and separate. As you can see from the picture, the over the wall syndrome, that this kind of way to collaborate actually limits the BIM-based project life cycles, since the activities are carried out one after another with limited interaction among disciplines. This way of collaborating, known as sequential engineering, has been proved not satisfactory for today's industrial demands in terms of cost, quality, time, and sustainability. It is due to its limitations, such as lack of collaboration, potential design errors, inefficient iterations. So, to overcome these limitations, many researchers claim to introduce concurrent engineering into construction industry. Concurrent engineering is a methodology that emphasizes the parallelization of the tasks by incorporating downstream concerns and maximize the information by increasing the interaction at the early stage. If you look at the pictures, the dashed curve represents the concurrent engineering. It encourages the maximizing the interaction at the early stage to avoid the potential design errors at the later stage. And if you look at the sequential engineering one, it actually has the huge potential for design errors at the late stage. So, in line with this, our team has already proposed a concurrent collaborative design paradigm called CBIM in our previous publication. So, feel free to check it out. It's a great paper. So this paradigm actually allow us to allow the different stakeholders use domain-specific software tools for design and collaborate in parallel, generating the federated models, checking consistencies, propose solutions, manage the object-level versions, and perform analysis and design collaboration, design optimization. So here, I would like to request assistance from the Pantheon in Rome to explain how we are going to support this paradigm. We would like to investigate several aspects: its manifestation, desirability, necessity, feasibility, implementation strategies, viability, and risk of adoption. So in this specific study, we focus on the manifestation and desirability. By referring manifestation, it means visualizing the concepts of the paradigm into the use case scenarios, the user interface, the system diagram, workflow diagram, etc., depending on who you are talking to, just trying to make the concepts more visualized and more easier to comprehend and convey the idea clearly. So, to explore the manifestation and the desirability, we have the objectives that to understand the role of interdisciplinary design changes, elicit and assess the attitudes of the interviewees towards the paradigm. So, to accomplish the objective, we adopted a design science methodology with 3 iterative processes in a user experience research manner, by designing and refining the artifacts through 3 rounds of interviews, including 75 people in total. So let's look at the last round of interviews, some demographic information. So for the last round of interview, we've conducted 9 focus groups, including 89 designers, including architects, MEP engineers, structural engineers, and BIM managers, and half of them possess 2 to 5 years BIM experience. And they're from 15 different countries and areas. Half of them are from the US. According according to the survey we distributed, and they actually, their least favorite activities during the detail phase collaboration are maintaining consistencies, dealing with the interdisciplinary design changes, switching platforms, and exchanging models. And in the interviews, we demonstrated 4 use case scenarios corresponding UI mockups, which representing different ability requirements for the system related to the problem identification ability, the analytical problem solving ability, and the implementation ability. So the screenshots you see in here is from one of our use case scenario called error correction. So here's a story we presented to the interviewees that in the Nordic country there is a convention, and I believe that it is also a convention in many other countries, that the layout of the heaters should be aligned with the layout of the windows. So in our case, the architect changed the layout of the windows. They split the window into 2 parts due to some interior design requirements. And in here, the MEP engineers also have to change the layout of the heaters to get aligned with the layout of the windows. In here, we show the interviewees the user interface, how this system can solve the problem by identifying the errors and then demonstrate the problem, propose the solution, and apply the solution automatically for the MEP engineer. So in the end, we received 85% of satisfactions for all of the 4 scenario-based solutions. And the interviewees believe that these concepts of the paradigm represented by the use case scenario can theoretically enhance the efficiency, effectiveness by facilitating the communication and interaction through across discipline directly through the models. So where is the remaining 15% of unsatisfaction? It lies under the summarized user requirements that the interviewees require to seek a balance between the automation and customization, which means that while they value the intelligent assistance of the system to help them deal with some problem, but they also emphasize on the freedom and flexibility to have their own focus time for their creation and also to follow their own pace to carry out some tasks. And the second one is that they require to seek a balance between the interoperability and the ownership protection, which means that when we show the use case scenario to them, they value the interaction directly through the models, but it also raised the concerns for the interviewees that related to the ownership protection and the trust among stakeholders when the model is not ready yet. So we abstract the user requirements into the system diagram, and this C-beam system representing the interaction between the user and the system, and this is the simplified version of the system. Basically, you can see that the designers can initiate 4 general use cases, including customized settings from the top to the bottom, and then detect the issues, review issues, and commit the resolution. And each use case can contain further use cases, which I will not expand in here. We can talk it later. And then we focus on the review issue use case for further workflow development. And in here, we will give an example workflow for the fully automated scenarios. So the users can initiate review issues, and the system will demonstrate the problem and then demonstrate the solution. The users can choose to approve and apply the solutions automatically or reject the solution and fix the problem manually. And in the end, they will commit the resolution and close the issue. So in the end, yes, I'm about to finish. I'm not chair, but okay. 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 To conclude, this study improved the understanding of concurrent design collaborative paradigm by designing 4 use case scenarios, UML system, and corresponding workflow. Second, according to the feedback, the proposed paradigm can theoretically enhance the efficiency and the effectiveness by increasing the communication and interaction directly through the models, where we also need to consider some limitation about the subjective biases in the user experience research and the limited generalization since our project is super complicated. And future work, the Pantheon again. So we will conduct a series of online experiments. Will take in total 3 hours, but not necessarily like one time. So if you know any students or professionals who are or who will become the architects, structural engineers, MEP engineers, who are interested in advancing the future collaboration, design collaboration, please contact me and help me to spread the news. I will post the news next week. So thank you, everyone. Let's shape the future of design collaboration.
Thank you very much.